This is the Hanmatek DOS1102 oscilloscope, which takes approximately 10 seconds to fully boot up. We have connected an input signal and used the auto set function, which automatically adjusts the oscilloscope settings to provide a clear, stable, and well-defined waveform. The utility button provides access to a range of useful menus and settings to explore. The backlight option allows you to adjust the screen brightness to suit your preference. You can also adjust the display lines and set the menu timeout time, controlling how long the menus remain visible on the screen before automatically disappearing. To carry out a self-calibration on the Hanmatek DOS1102, first press the utility button and scroll through the available options until self-calibration is displayed. Before starting the calibration, make sure that all BNC leads and probes are disconnected from the oscilloscope inputs. Once the inputs are clear, press the button to start the self-calibration process. The oscilloscope will then carry out a full internal calibration. Allow the process to complete without interruption. Once finished, the DOS1102 will be calibrated and ready for use. It is a good idea to perform a self-calibration from time to time, particularly if the oscilloscope has been used for an extended period or has been exposed to changes in temperature. This can help maintain the accuracy and performance of the instrument. Set up channel 1 to accept the input signal, making sure the correct coupling type is selected for the signal being measured. Also check the probe type setting and select either X1 or X10, depending on the probe being used. The limit button allows you to limit the oscilloscope's input bandwidth. Setting the limit to 20 MHz reduces unwanted higher frequency signals and noise, which can provide a cleaner waveform and improve measurement accuracy when working with lower frequency signals. If you want to capture a waveform and store it in the oscilloscope's internal memory, press the utility button and select Save. Using the available buttons, select Storage to save the current waveform. The waveform will then be stored in the DOS1102's internal memory for later viewing and analysis. You can save multiple waveforms, with each one stored as a separate waveform. The stored waveforms can then be individually selected and turned ON or OFF, allowing you to compare different captured signals on the screen. If you want to display specific measurements on the screen, press the Measure button. Select Add Channel 1 or Add Channel 2, depending on which channel you want to measure. You can then select the required measurement type from the list on the left-hand side. You can add multiple measurements as required, and each selected measurement will appear on the display. This allows you to view several measurements at the same time, such as frequency, voltage, period, duty cycle, and other waveform parameters. If you no longer require a particular measurement, you can remove it individually. Alternatively, you can use the available buttons to remove all measurements from the display and start again. Press the Acquire button to open the Acquisition menu, which provides several options for how the oscilloscope captures and displays the waveform. You can select different capture types to suit the signal being measured. The averaging function can also be used to reduce noise and fluctuations in the waveform. By adjusting the averaging level to suit the signal, you can produce a much cleaner and more stable waveform for easier viewing and analysis. It is worth trying the different acquisition settings while your live waveform is displayed. This allows you to see how each setting affects the waveform, and helps you choose the option that provides the clearest and most suitable display for your particular signal. The trigger menu is a very useful section of the DOS1102, helping to stabilize the waveform and produce a clear, steady display. You can select different trigger modes, including single, auto, and normal, depending on the type of signal you are measuring. The menu also provides different trigger coupling options, allowing you to select the most suitable coupling type for your signal. Another useful feature is trigger hold-off. This allows you to delay when the oscilloscope triggers, based on the time interval you select. Adjust the hold-off control to set a precise time period between trigger events. This can be particularly helpful when working with repetitive or complex signals, making it easier to see specific parts of the waveform clearly. Try setting the trigger hold-off to around 1 second. With a suitable pulsed signal connected, you should be able to clearly see the waveform or pulse occurring approximately once every second on the screen. Experimenting with the hold-off setting can help you understand how the trigger system works and find the best setting for your particular signal. With the Hanmatek DOS1102, you also have a useful zoom function within the horizontal time-based controls. This allows you to take a closer look at a specific part of the waveform without having to change the original signal. To use the zoom function, press the horizontal button to access the horizontal time-based options. Then use the scale control to adjust the level of zoom to your requirements. By increasing or decreasing the scale, you can zoom in on parts of the waveform and examine individual pulses, cycles, or other details more closely. This is particularly useful when you need to investigate a specific section of a captured or live waveform while maintaining a clear view of the signal. The DOS1102 also includes a useful maths function, which provides additional ways to analyze and compare signals. One of the available mathematical functions is the FFT, fast Fourier transform, which allows you to view a waveform in the frequency domain rather than just as a normal time domain waveform. The FFT function can be particularly useful for identifying the fundamental frequency of a signal and looking for harmonics or other frequency components that may not be obvious from the waveform itself. If you are new to using FFT on an oscilloscope, it is worth gaining a little more knowledge about how the function works and what the different settings mean. Understanding FFT will help you interpret the frequency spectrum correctly and get the most from this feature on the DOS1102. The DOS1102 also includes a useful maths function, which provides additional ways to analyze and compare signals. One of the available mathematical functions is the FFT, fast Fourier transform, which allows you to view a waveform in the frequency domain rather than just as a normal time domain waveform. The FFT function can be particularly useful for identifying the fundamental frequency of a signal and looking for harmonics or other frequency components that may not be obvious from the waveform itself. If you are new to using FFT on an oscilloscope, it is worth gaining a little more knowledge about how the function works and what the different settings mean. Understanding FFT will help you interpret the frequency spectrum correctly and get the most from this feature on the DOS1102. The DOS1102 also provides a useful cursor function for taking precise measurements directly from the waveform. Cursors can be positioned on different points of the signal to measure values such as voltage, time, frequency, and the difference between 2 points. This can be especially helpful when you want to examine a specific part of a waveform rather than relying only on the automatic measurements. Using the cursors gives you greater control when analyzing a waveform and can help identify precise voltage levels and time intervals. The DOS1102 also provides a useful cursor function for taking precise measurements directly from the waveform. Cursors can be positioned on different points of the signal to measure values such as voltage, time, frequency, and the difference between 2 points. This can be especially helpful when you want to examine a specific part of a waveform rather than relying only on the automatic measurements. Using the cursors gives you greater control when analyzing a waveform and can help identify precise voltage levels and time intervals. The DOS1102 also provides a useful cursor function for taking precise measurements directly from the waveform. Cursors can be positioned on different points of the signal to measure values such as voltage, time, frequency, and the difference between 2 points. This can be especially helpful when you want to examine a specific part of a waveform rather than relying only on the automatic measurements. Using the cursors gives you greater control when analyzing a waveform and can help identify precise voltage levels and time intervals. The DOS1102 features a useful set of multifunction control knobs, allowing you to make quick adjustments to the waveform without having to navigate through the on-screen menus. The vertical position control allows you to move the captured waveform up or down on the display. The control knob can also be pressed, which provides a convenient zero or center function. Pressing the vertical position knob automatically returns the waveform to its central reference position, making it much easier to quickly reset the display after making adjustments. The horizontal position control works in a similar way, allowing you to move the waveform left or right across the display. This is particularly useful when examining different sections of a captured waveform or when you want to position an event at a specific point on the screen. The trigger controls are also important when working with captured waveforms. They allow you to adjust the trigger position and settings so the oscilloscope can reliably lock onto the waveform. Correct trigger adjustment helps produce a stable and easy-to-read display, which is especially useful when measuring repetitive signals or examining changes within a waveform. These press and turn controls make the DOS1102 much quicker and easier to operate, giving you direct control over the waveform's vertical position, horizontal position, and trigger settings, while the press functions provide convenient ways of returning controls to useful reference positions. Capturing DC voltages with the oscilloscope. The DOS1102 can also be used to capture and display DC voltages. First, make sure channel 1 is set to DC coupling. In this example, we have applied a range of positive DC voltages, starting at 1 volt and increasing through 2 volts, 3 volts, and 4 volts, which can all be clearly seen on the display. The oscilloscope can also display negative DC voltages. By changing the input polarity, we can capture voltages from approximately +1 volt down to -3 volts, allowing both positive and negative DC levels to be viewed easily. Using the measurement menu, we can add a voltage measurement such as max. Once selected, the measured voltage is displayed on the left-hand side of the screen, making it easy to monitor the voltage level while observing the waveform. For this test, we have also adjusted the oscilloscope settings to allow us to capture higher DC voltages, up to 10 volts positive. This demonstrates how the DOS1102 can be used not only to view waveforms, but also to accurately monitor and measure different DC voltage levels directly on the screen. Saving and recalling oscilloscope waveform settings. Another very useful feature on the DOS1102 is the ability to save and recall your oscilloscope settings. This is particularly helpful when you have spent time adjusting the oscilloscope to display a waveform exactly how you want it and you may need to return to those settings later. To save your current settings, press Menu, then select Wave. From here, go to Type and then select Configure. You will be presented with a number of memory locations, allowing you to choose a setting number from 1 to 8, etc. Select the number you want to use for your stored configuration and then press Save. The oscilloscope will now remember the current setup, including the relevant waveform and display settings. You can now change the oscilloscope settings and adjust the controls so that the display is completely different from the original waveform. This allows you to demonstrate how easily the stored configuration can be recalled. To restore the previous settings, simply press Menu, select Wave, go back into Configure, and choose the setting number where you previously saved your configuration. Then select Load button. The DOS1102 will then restore the saved settings, bringing the oscilloscope back to the configuration you originally stored. This is a very useful feature, especially when working on repeated tests or measurements. Instead of having to manually adjust the vertical scale, horizontal time base, trigger settings, and other controls again, you can simply save the configuration and recall it whenever required. With up to 8 or more different setting locations, you can store several different test configurations ready for future use. Viewing captured measurements on the DOS1102. With the DOS1102, you can easily view all the measurements captured from the live signal at any time. This is particularly useful when you want to see several measurement values together without having to select each measurement individually. To view the measurements, simply press the Measure button. Then press the Show button located next to the display. The oscilloscope will then present the available measurements for the live waveform currently being captured. This gives you a quick overview of the signal and allows you to see the measurement information directly on the screen. This is a very useful feature when analyzing a waveform, as you can quickly check the different measured values while the signal remains live and is continuously being captured by the oscilloscope. Display in G and triggering two stable signals at the same time. With the DOS1102 oscilloscope, you can capture and display two signals at the same time using channel 1 and channel 2. With the trigger set correctly, both waveforms can be displayed clearly and remain stable on the screen. Start by connecting a signal to channel 2 and press the Auto button. The oscilloscope will automatically adjust its settings and you should now have a stable channel 2 waveform on the display. Next, turn on channel 1 and connect your second input signal. Press Auto again. Both channel 1 and channel 2 waveforms should now be visible. However, depending on the two input signals and the current trigger settings, you may find that the waveforms are moving across the screen and are not completely stable. To correct this, press the Trigger menu button and change the trigger source to channel 1. Now adjust the trigger level so that it falls within the voltage range of the channel 1 waveform. Once the trigger point is correctly positioned, the display should become stable. It is important to remember that if you move the trigger level outside the voltage range of the selected input signal, the oscilloscope may no longer be able to trigger correctly and the waveform can become unstable or start moving across the display. Simply move the trigger level back within the waveform until a stable display is obtained. You can also experiment by changing the trigger source between channel 1 and channel 2 to see which signal provides the most stable trigger. This can be particularly useful when the two input signals have different frequencies or waveform characteristics. Once both waveforms are stable, you can manually adjust the horizontal time base to expand the waveforms across the screen. You can also adjust the individual vertical settings for channel 1 and channel 2 to obtain a clearer view of each signal. Measurements can then be added for each channel. For example, you can select peak-to-peak voltage, VPP, for channel 1 and channel 2. The measurement results are displayed on the left-hand side of the screen, allowing you to compare the two signals while viewing their waveforms at the same time. Also check the input coupling settings for each channel, such as AC or DC coupling, as an incorrect coupling selection can affect how the waveform is displayed and, in some situations, how easily a stable trigger can be obtained. Another useful feature is the trigger level knob. After making adjustments, simply press the trigger knob to center the trigger point again. This provides a quick way of returning the trigger level to a central position without having to manually turn the control back. Being able to display two signals simultaneously, select the appropriate trigger source, Adjust the trigger point and compare measurements from both channels is particularly useful when comparing two related signals or checking the input and output of an electronic circuit. We hope you have found some of the features and functions we have demonstrated on the DOS1102 oscilloscope useful and informative. Throughout this video, we have shown several of the oscilloscope's useful features, including capturing DC voltages, displaying measurements, saving and recalling oscilloscope settings, viewing two signals at the same time, and using the trigger controls to achieve a stable waveform display. There are many different functions available on the DOS1102, and we will continue to explore these in future videos to help you get the most from your oscilloscope. If you found this video helpful, please consider subscribing to our YouTube channel. We would also appreciate it if you could leave a comment below and let us know what you think, or tell us if there are any particular oscilloscope features you would like us to demonstrate in future videos. Your subscriptions, comments, and feedback really do help support the channel and encourage us to continue making more videos covering oscilloscopes, test equipment, electronics, and practical testing. Thank you for watching, and we hope to see you again in our next video.